last piece in this probability standard is to do with risk. So this is looking on page 71 of your notes. So the key information. Well, when we're talking about risk has a very specific meaning in statistics. And we've got two types of risk that we talk about. We talk about the absolute risk, and this is just referring to a probability. Okay. Then we also have a relative risk, and this is a little more tricky to calculate, and this is where our excellence level stuff comes in, and sometimes at merit level, mostly at excellence level. So if I was, for example, just to look at an absolute risk, So we've got the example of in our notes is they're talking about a group of 5,000 patients, and they suffer from some particular skin condition, and they were split into two groups of 2,500 each. Now, one of those groups were given a new drug. So one of these groups had the new drug, and the other group had a placebo. Now, placebo is a very specific term in science and refers to being given a sugar pill. So we want to know, sometimes people can feel better just by feeling that they're getting treated. And that's what we want to know, is what's the chance that somebody feels better just because they've been treated compared to actually feeling better. And so therefore, is the drug actually doing anything, or is it just the fact that the person's being treated that makes them feel better? So we were told from those that were given the new drug, 399 of that 2,500 reported itching as a side effect. From the placebo group, that second group, from that 2,500 that they had, 42 of those people reported itching. So we can calculate the probability of itching depending on whether they were in the placebo group or in the drug group. So if we just look at the drug group, we can say the absolute risk, which is just a fancy way of saying what's the probability of itching for the new drug group, and that's just going to be 399 over the 2,500. Equally, the absolute risk for the placebo group of itching is just our probability of itching in that group, which is there were 42 of those people out of the 2,500 that reported itching. Okay, so that's absolute risk. Now let's think about relative risk. Relative risk is a ratio. That's why it's called relative. It's a ratio of one thing to another. And if I'm interested in the ratio of itching, are there more people that itch and that take the new drug compared to the proportion of people in the placebo group who drug, that is going to be my relative risk. So if I, for example, ask for the relative risk of itching, then what I want to do is I want to have the absolute risk for itching given that they are in the new drug group compared to the absolute risk of itching given that they are in the placebo group. So now, if I simplify this 399 over 2,500, that is a decimal is 0.1596, and this is a decimal would be 0.0168. So my absolute risk of itching, given that I'm taking the new drug, is 0.1596 over the absolutes of risk of itching, given you're in the placebo group, is our 0.0168. Now if I divide that out, that's going to give me a value of 9.5. I'm just going to one decimal place for this. And now I've got to think about, well, what does that mean? So if I look back to the new drug group, there were a lot more people. There were 399 people in this group who reported itching as a side effect, compared to only 42 of the 2,500 in the placebo group who reported itching. So there's a lot more people that reported itching in this group than this group. And in fact, that number 399 out of the 2,500 is 9.5 times as big as this 42 out of 2,500. And that's what our risk is. So we need to just interpret this into a sentence form now. So we need to be able to say that the relative risk of itching with the new drug is 9.5 times as likely as with the placebo. Okay, so taking the new drug, you are much more likely, you're 9.5 times as likely to be having itching with the new drug than you are with the placebo. Okay, now let's just have a look at, if we on page 72 here, we want to look at a specific example from a table format now rather than just from a word format. So let's have a look at this one. Okay, so I'm just going to rewrite this example. So what we have is we have Wiramu keeping a track of whether he walks or bikes to school and whether he is late. Okay. So we've got our total. We know how many times he bikes and walks and whether he's not late or whether he's late. Okay, and we're told he counted up 50 times. And so from that 50 times, there were 28 times that he rode his bike and 22 times that he walked. And from those 50 times, there were 14 times that he was late to school and 36 times that he was not late to school. From the 28 times that he rode his bike, 24 times he wasn't late and only 4 times he was late. From the 22 times that he walked, there was 10 times that he was late and 12 times that he was not late. So we want to, first of all, part A is asking us for the absolute risk, so just a probability, that Wiramu is late to school. Okay, so that's just the probability of being late, and we know that in total, because it's just talking about Wiramu being late to school, so it's not saying whether he was on a bike or walking, so this is from all of those 50 times, there were 14 times that he was late. So that is 14 out of 50, or 0.28. Okay, that wasn't too bad. Let's find the probability that he, part B, calculate the probability he's late on a day when he walks to school. So late on a day when he walks to school. So this is telling us a conditional probability. If you want absolute risk of being late given that he walked. So I want the probability of being late given that he walked. And so we know from all the times that he walked, given that he's walked, we're only interested in the times that he's walked. From those 22 times, he was late 10 times. So 10 times out of the 22, which is 0.4545 to 40p. So that's for the absolute risk. Then the third one, part C, says calculate the probability he's late on a day when he bikes to school. So now we're talking about from when he bikes to school, how often is he late? So we want to know the probability of being late given that he biked. So from the 28 times he biked, 4 times he was late. So it's 4 out of the 28, which as a decimal is 0.1429 to 40p. Okay, now part D. Part D now asks us calculate the relative risk of being late when he walks to school compared with when he bikes. So what I want to do is it says compare being walking with biking. So I want to put the probability of walking on the top and biking on the bottom. So that's a good hint to know the order that they've given it to it. So the relative risk of being late when he walks, the probability of being late given that he walks to school, over the probability of being late given that he biked. So I want the relative risk, and I'm just going to call this RR. And that's going to be my probability of being late given that he walked to school divided by the probability of him being late given that he bikes to school. You'll notice both of them, the event that we're talking about is being late, and it's only the condition that differs. So that's my 0.4545 divided by 0.1429, which gives us 3.18. So now we've got to think, well, what does that mean? So we're comparing walking with biking. So if I look at the number there, the probability of walking and being late compared to the probability of biking and being late, there's much bigger chance that he's going to be late when he walks to school than when he bikes to school. And in fact, being late to school when walking is 3 times more likely than if he's riding his bike. So that's what we want to interpret. Okay? So we want to be able to say, I'll just move this over. We want to be able to say that the relative risk of Wiramu being late to school when he walks compared to when he bikes is 3.18. Okay. Another way to interpret that is he is 3 times more likely to be late when he walks to school than when he bikes. And there we go.